Okay, now let's learn how to create new variables using dplyr in a data frame. Okay, so let's do this first. Let's use the base R way to do this. For example, I am interested in the total of departure delay and arrival delay, right? In using base R, I could say this. For example, I could create a new variable with the $sign right there, flights, dollar total delay. If I run this, I will get an error because there's no such column yet. So I will say this is equal to the flight date set dollar the arrival delay plus flight date set dollar the departure delay. Right? If you add these up, you will get this new column, which is the total delay, and we see those values right there. If there's any NA value in one of these columns, we will get back NA, as you can see here, for example. Or we can also directly check the flight's data frame. If you go to the end, it will be the last column right now. So this is how we can do using the base R. And in dplyr, what we will do is we will use the mutate function. So the name of the function is called mutate, like this. So we're going to mutate the data frame. Okay, so we'll take flights, use as input into the mutate function, and here we will calculate basically the new column, kind of very similar to what we did over here. But the main advantage is we don't need to refer like this, and also here to the data frame over and over again, because we are already now operating within this data set. That's one of the main advantages of dplyr, so we don't need to, it's easier to use basically. So I will say, hey, take arrival delay, and it will, basically we are telling R that, hey, we are inside this data frame. You already know, just take the arrival delay in that column and the departure delay in that column, add them up. So if I were to do this now, let's run. If I go to the end, it's at the end. You see, it's basically, it will take this and make it a column name, like this operation. This doesn't look nice, so let's give it a name as well. Let's call this total delay 2, so we can compare this with the base R. Okay, let's go to the right. The total delay was created by using base R. This is total delay 2, created using dplyr mutate function, and all the values are the same, so we are good on that. Okay, so one thing though, here this column is just calculated, but it's not saved into the data set, right? If I were to take the flights data set, if I were to check it now, put it here, flights, run it, go to the right, we won't see the total delay 2. This one was created using base R, still there, but the next column that we have created here, total delay 2 using mutate, not saved, so it's not persistent. It will not stay in the data frame. If you want to save this, you need to do this. We can say flights is equal to, and then so it will basically create this new column called total delay 2, and then save that back into the data frame, right? So this is how you can do that. And if I run this, you can see 2 columns here. Go to the right, and you see both total delay and total delay 2 are there. Okay. For example, another column I was thinking that would be useful is calculating the speed of the airplane, right? So how can we do that? We will take the flights data set, and then we will create a new column there. So we are directly putting flights equal to, then flights, and then pipe that into the mutate function. And inside mutate, we are going to create a new column called speed. That's with double E there. So speed is equal to, go down, the speed is equal to the distance, it was already given in the dataset, divided by airtime, and airtime was given in minutes. So if I were to divide this, distance was in miles, airtime is in minutes, I will get miles per minute. Rather than per minute, I think it will be much easier to interpret per hour. So let's divide that minutes by 60 to get hour, and then distance by you know, divided by airtime divided by 60 will give miles per hour of the airplane. Right, let's run this. Now let's check how this flight looks like. Go to the right. Can you see we have the delay columns, the total delay columns there, and the speed of each airplane. So 370 miles for that one, 374 miles, 408 miles, and so on. So for example, a simple example would be after calculating the speed of each airplane, of each flight, we can ask, okay, what is the maximum speed in all of the flights? So right now it's already calculated there. So let's take flight data set, and we can use a range function to sort the data set, right, based on the speed. And I will put a minus here so that it's sorted in a descending order. Let's go to the right. 703 miles per hour is the fastest airplane, and the flight happened between LaGuardia Airport and the Atlanta Airport. And you know, we can get more information here. The carrier was DL. It happened in 2013, 25th of May, right? So it seems there was a 9-minute departure delay, and it arrived 14 minutes earlier than scheduled. So it sped up quite a bit after it took off, it seems. All right.